Okay, continuing in 9.4. Three people are pulling a car using ropes as shown in the diagram with all forces given in newtons. The 245 Newton force is pulling the car directly forward. That's this one in the middle. Find the magnitude and direction of the resultant. All right, well, similar to the last couple problems we did, the big thing we need to do is measure angles in standard position. So this one's going to be 50 degrees. This one's going to be 90 degrees. And this one is 120 degrees. The only real difference with this problem is now we have three vectors. So I'll call these vectors A, B, and C. So we'll need to find AX, BX, CX, add all of those to get RX. And then similarly, we'll need AY, BY, and CY, and add all those together to get RY. So AX is 175 cosine 50. And AY is 175 sine 50 degrees. BX is going to be 245 cosine 90 degrees. And BY will be 245 sine 90 degrees. Now, just thinking about these, I really didn't need to write that because clearly this vector is going completely in the y direction. So this has to be 0 and this has to be 245. So you could just write those 0 and 245. If you don't recognize that, that's fine. Use the 245 cosine 90, the 245 sine 90, type it into your calculator. But we can clearly see that vector is totally in the y direction. There's no x component there. All right, CX is 275 cosine 120 degrees, and CY is 275 sine 120 degrees. All right, adding these together, 175 cosine 50 plus 0, I'm not going to do that one, plus 275 cosine 120, negative 25.01. And doing the y's, 175 sine 50 plus 245 plus 275 sine 120 is 617.21. All right, so R is Rx squared plus Ry squared. That's actually R squared, which means R is negative 25.01 squared plus 617.21 squared, square root of that answer, 618. I'll give three significant digits since we had three significant digits in our original problem. And tangent theta is Ry 617.21 over negative 25.01. So tangent inverse of 617.21 divided by negative 25.01. Negative 87 degrees. Again, that's the wrong angle, correct? Because that's down here in quadrant 4. Clearly our answer is up in either quadrant 1 or 2. So we need to add 180 degrees. So I'm going to call theta 92.3 degrees, since all of our given angles were given to 1 decimal point. I'll give that one to 1 decimal point. Okay, so really the only new thing in that problem was that we had 3 vectors instead of 2. But you can see how this could go if you had 3 or 4 or 5 vectors. Really doesn't matter. Okay, next couple problems have something a little bit new. It says, assuming the vectors are in equilibrium, solve for T1 and T2. So equilibrium means the forces all added together are perfectly balanced so that nothing is moving. In other words, I guess I'll call this T3, T1, T2, and T3. If I take T1x plus T2x plus T3x to get my R sub x, that's going to be 0. It's not moving in the x direction. So Rx is going to be 0. At the same time, T1y plus T2y, I know that's a funny looking one, T3y. When I add those together and I get Ry, that's also going to be 0. So that's what it means to be in equilibrium. Nothing's moving. It's not moving in the x direction. It's not moving in the y direction. All right, so now look at T1. T1 is completely in the x direction, isn't it? No movement in the y. So T1x is going to be negative T1. Negative because it's going left. And T1y is going to be 0 because it's not moving in the y direction at all. T2x is going to be T2 cosine negative 37.2 degrees. And T2y is going to be T2 sine negative 37.2 degrees. And finally T3. T3 we know our force. So T3x is going to be 255 cosine 58.3 degrees. And T2y will be 255 sine 58.3 degrees. All right, so adding these together, I get 0 equals negative T1 cosine negative 37.2 degrees is 0.797, so plus 0.797 T2 plus 255 cosine 58.3. I'm going to call it 133.995. That doesn't do much for me because this equation has two things that I don't know, T1 and T2. But if we go over to this one, I think we're going to have good news. 0 equals, it's going to be T2 sine negative 37.2 is negative 0.605. Negative 0.605 plus 255 sine 58.3, 216.957, 216.957. And now notice this equation only has T2 in it, so I can get T2 all by itself. I can subtract the 216, divide by negative 0.605. So that's going to be, when I subtract that, it's going to be negative 216.957. And then I divide by negative 0.605. And I get T2 is, I'm going to call it 354 because this had 3 significant digits. So T2 is, what did I say, 354. Now notice I can take that answer, plug it in there, and I can get T1 all by itself. In fact, if I just add T1 to the other side, T1 is 0.797 times 354 plus 133.995, and I'm going to call that 416. All right, so that's what you're going to do with these equilibrium problems. You're just going to set up the equations for Rx and Ry, setting them equal to 0, and you should be able to solve. All right, let's see if we have time to do this last one. All right, the only thing with this last one is first I got to change this angle. This is add 90 degrees, so it's 162.5 degrees. And I'll call this, that's T1, T2, T3. Slide my paper over so you can see. All right, so same thing has to happen. 0 has to equal all the x values. So the x values are going to be t1 cosine 22.6. For t2, again, t2 is completely in the y direction. So t2 doesn't have an x value, doesn't have an x coordinate. So plus t3 is 427 cosine 162.5. So you might notice from this equation that I can get t1 all by itself right now. So t1 is, I would subtract that to the other side and then divide. So it's going to be minus 427 cosine 162.5 minus, going to move to this side, I typed in wrong here, cosine, let me start over. All right, move that over. It's minus 427 cosine 162.5, and then I divide that by cosine 22.6. Oops, I hit sine, didn't I? Rats. Divided by cosine 22.6. All right, so that's going to be 441. T1 is 441. And then looking at the y components. So these were the x components. Looking at the y components, again, because we are in equilibrium, they have to add up to 0. So T1 is going to be 441 sine 22.6 degrees. T2 is completely in the y direction, but notice it's going to be negative because it's going down. So negative T2 is going that way, plus 427 sine 72.5 degrees. So if I just move the T2 over, I've got my answer. T2 is 441 sine 22.6 plus 427 sine, ooh, I wrote 72.5. Oh, that's bad, 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 bad. It should be 162.5 degrees. I got to use the angle in standard position. 162.5 degrees. 298, we will call that. Okay, so this is what you're going to do with these equilibrium problems. You're going to set up the TXs, the TYs, and then they're going to have to add to 0. And when you add to 0, one of the two equations, depending on which one, will only have one letter in it. Like this one only had one letter in it. For this problem, this one only had one letter in it. So you'll solve for that letter first, be it T1 or T2, and then you'll use that to plug into the other equation and solve.